Hey guys, my name is Stuart, and today we're going to be having a look at what resistance and resistors are all about. So to get started, circuits all have some element of resistance in them. All conductors have an element of resistance. And in that case, we generally negate it because it's very, very small. But in some specific cases, we actually want resistance. And that's when we introduce the component of a resistor. Resistors come in all different sizes, and I've got a couple over here that you can see. So this is a very big resistor. You can see that it measures at 1.8 ohms. I don't know what that J is for, and it's rated to take 10 watts, and I will talk about what that means just now. Then we've got other types of resistors, and I'm sure you guys have seen this at some point, these kind of resistors. Let's get the camera to focus. There we go. And these resistors are more common in electronics and digital platforms, but this is actually quite a big resistor. This is a 1/2 watt resistor, and so we're talking again about the watts. And then we've got some smaller resistors. This one, which is probably the most common one that we'd be using, is a 1/4 watt resistor, and you can see it's got those little colorful bands, and those colorful bands are what are used to show the resistance, and we'll talk about that later as well. And then we've got an even smaller resistor. That's a tiny little one over there, and that's a 1/8 watt resistor. But these are all leaded axial resistors. You don't have to worry too much about what it's called there, but this is one package type. So it's a type of resistor. Then we've got other ones, and this is where things get really crazy, is that you've got what they call surface mount resistors. And this is what is being used in computers and modern electronics. And you can see that is a 1/4 watt resistor on a surface mount package. So it's exactly the same as this. It's just much smaller and much easier to fit lots of them into a circuit board. And then, if I can get it onto my finger, we've got an even smaller resistor. And that is him over there. That's a tiny, I don't even know, it's maybe a 1/20th of a watt resistor, and that's what's used in cell phones and very, very small electronics, which is pretty crazy because essentially it's doing exactly the same thing as this, but obviously taking a way, way smaller amount of power to go through it. Right. So where are things like this used? Well, I've got some examples over here. You can see this is a little LCD panel, and you can see there along the back we've got a bunch of surface mount resistors, and it even tells you R7, R5, R4, there's R6 over there. Those are all surface mount resistors that are limiting current to different things. This is not the only component that comes in this kind of a package. There's diodes, there's LEDs, there's a whole bunch of different things that that look like this in modern electronics, but if they're black and they've got a little number on them like that, particularly if it says R3 next to it, that means that it's resistor 3 on the circuit diagram. Then get a little bit more crazy. This is the tail light, or the inside of what a tail light looks like, of a Harley Davidson motorbike. And you can see there are a whole bunch of components that look very similar. That one over there that says C10, that's a capacitor in the same package type as the resistors, but there's a whole bunch of resistors here too. You can see there, that's R number 15, there's R number 23, and you can see all different sizes. There's some really big ones over here. You can see that's also probably about a 1 watt resistor over there and over there, along with a whole bunch of other components. And this is what they would call an integrated circuit, because there's a lot of circuitry going along, and that's an integrated circuit there as part of the whole. These, if you're interested, are the LEDs that make the light shine. So I think that's the red one, and then there's some yellow ones that are for the indicators, and the C and the A are standing for cathode and anode. So if you've covered light emitting diodes already, then that's what modern LEDs in a surface mount package would look like. Right, so we were talking about resistors and resistance. Everything that is in a circuit has some element of resistance. And as I was saying before, sometimes it's good, sometimes it's useful, and sometimes it's bad. Sometimes we don't really want the resistance, but it's just there. So if we have a look, we can take, for example, this wire, and I'll use this multimeter, and we can actually measure the resistance of things using this multimeter. And we know that the symbol that we use to talk about resistance is the Greek symbol omega, or for ohm. And so I'm going to take my multimeter and I'm going to turn it onto the ohm reading, and we can start using this to measure the resistance of things. So if I'm going to take the leads and I'm going to hold the one end on this side and the other end on that side, and you can see that the numbers will start moving, and it's looking for a resistance. So this one's not a super sensitive multimeter, and it's saying that, hey, I don't see any resistance here. There's a 0 resistance. Now, in reality, there is a tiny amount of resistance, but it would probably be in 0.001 of an ohm or something, a very, very small amount. So that's good, because this is a piece of solder, and we use this to join electronics together. So we want it to have a very low resistance. If we have a look at something like this, here's a metal small shifting spanner. It's metal, so it should conduct very well. So it probably also will have quite a low resistance. Let's see, yeah, it's struggling to find it, but that's quite high. Oh, it's probably because I'm measuring it across something that doesn't have a very good contact, but this is making it go pretty crazy. Right, let's try something else. Let's have a look at this spring that I've got. It's a carbon steel spring, so it should have quite a high resistance for something that's made out of metal. And we can see here it's measuring almost exactly, well, that's going down now, 654. Okay, so this is giving us about 0.2 ohms. The surface, the oxidization on the surface of metal often also introduces a non sort of stable resistance, but we're getting 0.3 ohms of resistance on this. So it's very low resistance, but it's still, we can actually measure the resistance on something like that. If we look at something like a pencil, wood is a very bad conductor. So if we put it on here, we'll see that it says 40 mega ohms. That's a very, very high resistance. But the graphite inside the pencil should have a much lower resistance. It'll still be high. And so what we can do is actually, don't try this at home, but I'm going to snap this pencil, and I am going to find the lead. It's actually a graphite core. I'm going to stick this probe into it over there and then measure the tip, and then we'll see that's actually quite a low resistance. So that's giving us 14 or 12, between 12 and 14 ohms of resistance, and it's only fluctuating like that because I can't really get a good contact in the back of this broken pencil. But there we can see the core graphite lead of our pencil is giving us about 9.3 ohms when I get it to make good contact. So the core of our pencil is much more conductive than the outside of our pencil. And obviously if we move the contacts closer, the resistance will also change. So if we put it close together, we can see now it's only 12 mega ohms, which is really, really high. It's very, very unlikely that this would conduct an electrical current. Right, if we have a look at this big resistor, a component that we want to have a resistance, we can measure this as well, and it should give us pretty close to 1.8 ohms. And you can see there it's giving us 1.7, and normally our capacitors, or at least resistors like this, will give us a tolerance to say it's between or 10% accurate to 1.8 ohms. So it could be slightly less, or it could be slightly more than 1.8 ohms. And here you can see that we're getting quite a stable 1.7 ohms. So this is giving us quite a good stable reading. And as this gets a little bit hotter, it probably will change, because the resistance of materials is often also affected by the temperature of the material. Right, so that's 1.8 ohms. So that's a very low resistance actually, but it's quite a high power rating. So this can take a lot of current, because as a resistor resists electricity, as it has a current going through it, the electricity that it's resisting gets turned into heat. And so the more electricity that it's resisting and the more current that's flowing through it, the more heat is going to be dissipated through the resistor. So 10 watts is how much heat this resistor can handle before it starts to get damaged. And these ones, these smaller ones, this is 1/4 of a watt. So this can take way less power before it starts to get too hot and essentially burn up. And so this should be a 220 ohm resistor roundabout. So yeah, no, that's a lot more than that. Yeah, red. So that's 2020 ohms. So that's a 2.16 kilo ohms. Right, but because it's much smaller, it can only take, or it can dissipate a smaller amount of heat. What's really interesting to have a look at is that some materials have almost zero resistance, and this is very special materials, obviously, that have been developed for this purpose, and they're called superconductors. And if you're interested in superconductors or reading up about that, this Wikipedia's got some pretty good articles on that. You can read up about it. The last thing that we'll have a look at is a speaker. Speakers are essentially a coil of wire, and at some point I'd like to take us through how a speaker works, but because it's a coil of wire, it will have a resistance, and you can actually see it tells you that's a 8 ohm resistance, and we can measure that again and verify this. So we'll take the two leads, we'll put the one on the one side, the other on the other side, and it should give us, here we can see it's 7.7 ohms. So not super accurate, but close enough to 8 to know that this speaker has a resistance of 8 ohms, and you can see that it also gives us a power rating. The power rating is 0.5 watts, and there's a mathematical link between the power and the resistance and the current and the voltage, and that's similar to Ohm's law, but we're not really going to go into that right now. We're going to use Ohm's law in a circuit simulator now to go and experiment and just test that practically, because I can show you this stuff here, but you don't have it in front of you like I do, and we're going to then now move on to using a simulator to do these similar experiments and play around with resistance in circuits. Have fun.